Hello, I'm Robert.
And I'm Richard.
We're twins, and together we make up Tuber Studio.
A little bit of background about us. Back in my college days, I was on a cartoon called the Aligning Concept. Aligning Concept was a cartoon at the University of Illinois Champaign-Urbana, which allowed us to build essentially what looks like a supercar. As such, I was in charge of the body and chassis design for the past 3 years. Because of this, I needed to figure out how to manufacture the carbon fiber chassis and the carbon fiber body. And manufacturing both required the use of molds. These molds are very expensive if we end up purchasing them from an outside company. So therefore we had to get creative because our cartoon didn't have a lot of funding. As such, I ended up designing and manufacturing my own CNC machine. A little bit about the CNC machine. It's massive. Massive. This is because the Aligning Concept car that we're building had to be was almost as big as a full-size vehicle. As such, the build space is 1.5 meters by 1.3 meters by 1 meter, which essentially allows us to build any sort of mold, even for a full-size vehicle. Some more specs about the machine. It's running a 2.2 kilowatt spindle. It's got a dual racking pinion on the y-axis, a single racking pinion on the x-axis, and a ball screw for the z-axis for 2 reasons. One reason is because it's a sturdier and more accurate system for the z-axis, and the second is so that the spindle column doesn't just completely fall when the stepper motors have no power and we turn the machine off. The x-axis is actually supported in a very small section in the center, right here. This is because it allows us to get the maximum bed travel for the least amount of linear rail purchased, and maximizing the cost effectiveness of the machine. We didn't necessarily need all that support across the entire x-axis, especially because we could center the molds onto the x-axis bed. A little bit about the y-axis. The y-axis is designed to be sturdy by having a dual column CNC router design. One column on the left side, one column on the right side. This allows us to have the maximum stiffness for the least amount of rail as well, and the least amount of aluminum used for the frame. The CNC machine runs on LinuxCNC, which I am so happy about because I wasn't about to write my own CNC software. LinuxCNC is a free open source Linux-based operating system, which also has some built-in setups and systems for you to actually run your CNC machine off of. It's really simple to use once you actually get the ins and outs of the software and know how to set it up. Once you've completed your setup, you would open up something called My Machine, and that would just be the actual application in the operating system that lets you operate the machine. The operating system and the application that you open for your machine can be customized to whatever you need to. So you could have the spindle RPM added to it, you could change the feed rate, you could change whatever you want to, quite frankly, which is very nice, as long as you know a little bit about how to actually manipulate the software. So the main purpose in having any sort of CNC machine is to be able to use it to make something else. In our situation, that happened to be a small-sized vehicle. Designing and building my own supercar has always been a dream of mine ever since high school, so having this opportunity in college was incredible. But it also took an insane amount of work. I put in something like 1,000 hours into the car alone, and we also had other team members as well helping us out with the project because this is a car team on campus. Each mold alone, specifically the large ones, took around 16 to 20 hours to finish up machining. And that is just the machining process itself. The molds would then need to be sanded down, then they would need to be primed, sanded some more, and then prepped for layup. And then finally we could actually lay the carbon fiber into the mold, which also take another couple hours. And we try to make most things in carbon fiber because of its lightweight and high strength. That included the body panels, the chassis panels, and even the rims, which we didn't complete by the time we graduated. However, the next year's team is going to complete that. Okay, there we go. Your turn, buddy boy. One of the main benefits to the CNC router I designed was how easy it was to set up. The machine is designed in 3 separate components. the x-axis, the y-axis, and the z-axis, all of which can be easily removed and then put back together, which makes it easier for transporting, especially in a confined system like a U-Haul, for example. The machine also turned out to be incredibly reliable. The thing ran for at least 500 hours without any sort of issues popping up. Nothing mechanically failing, nothing electrically failing, just nice and solid, no issues. I think at some point I looked into how far the machine traveled, as in how much distance each axis actually moved, and it was several marathons at that point. Additionally, it's also easy to maintain. The components were easy to source, and they're also easily accessible too, because of the nature of how it was designed. So if a stepper motor happened to fail, which thankfully it didn't, we could easily access them and replace them and get the machine up and running within half a day. And lastly, and most importantly, the price to performance was amazing. The machine cost so little when you actually look at the build space and how accurate it was for what we were specifically doing and how fast we could cut foam and other materials. I have to say, I'm very happy with how the CNC machine turned out. However, there needs to be a few improvements for me to be completely satisfied with the build. One of the main problems with the CNC router was the linear rails that were chosen. These linear rails were cheaper than linear guideways, but they also were a lot less stiff than linear guideways. As a result, they allowed for a lot more deformation under larger loads, specifically with higher density foam, and on top of it they caused a lot of chatter problems. So that would be one of the first things I would like to improve. Thankfully, there is only one set of linear rails that would need to be replaced in the CNC machine, and that would be the Z-axis linear rails. These linear rails undergo the greatest amount of vibration and the greatest amount of torque because of how long and tall the Z-axis spindle column is. Another thing I noticed when I was filming this video was that the Y-axis and Z-axis frame tends to not be as firmly planted to the ground as I would like to. That isn't necessarily a big issue when it comes to the finish of the parts being made, although that would be nice to address sometime in the future. From the electronic side of things, it would be nice to replace all the open loop stepper motors with closed loop stepper motors. This is so that we could achieve greater accuracy, prevent lost steps and lost motion, and also have a safety in place in case the machine crashes itself. Because if the machine crashes itself and the stepper loses steps, then it would automatically shut down the machine. The wire management also needs to be improved greatly. As you can see from the video, we're using cardboard and a popsicle stick as our wire management, and a very creative bungee solution on the x-axis as well. Now these all work, but they don't look as professional, and it would be nice to upgrade the wire management solution a little bit. Lastly, it would be nice to add a second vacuum pinion to the x-axis, because the x-axis is the axis that is required to transmit the largest amount of force. Sometimes the molds that we put on the machine, and the x-axis specifically, weigh upwards of 200 to 300 pounds, and as a result it would need to have the force behind it to be able to accelerate the mass back and forth and actually machine the part properly.
Hey there, Robert here. If you made it this far in the video, that's pretty cool. This is our first video, so it really means a lot to us. It's been a blast working with Richie on the CNC machine for these past 2 years. What's even cooler is that Rich and I have some new projects and videos planned for the future. I guess this is where I go into the obligatory please subscribe portion of the video, so yeah, do that. Based on my channel's highly advanced YouTube analytics, 0% of our viewers are subscribed by the time of making this video. That is, unless you are one of the 22 people who subscribed 10 plus years ago. So, yeah. Either way, any amount of support would be greatly appreciated, whether that's liking, subscribing, commenting, or sharing this with a friend. Anyways, that's it for this video. I hope you have a great week, stay safe out there, and I hope to see you here again for next video.